Hi, everyone. This is Dylan Wilks here with Orange Photonics. I'm the CTO, and I'm really happy to have you along with us here, and I really appreciate you spending your time with us. Today, we're going to talk a little bit about Delta-8 and Delta-10 THC and all the complexities around both of them. Really, these two cannabinoids deserve a lot more recognition than they probably get, at least Delta-10 THC, and as well as some more understanding because we've seen a lot more of both of them cropping up in some of our light lab tests that we've seen our customers running lately. So I'm assuming the market as abroad is seeing a lot more of these. So let's go ahead and get started. As many of you know and are probably aware, Delta-8 THC in particular has a lot of discussions going on about the legality and some of the nature of whether it should be allowed or not. And there's definitely plenty of resources out there to learn about that. So I'm going to try to stick really hard to the science side of things here. I'm going to talk about how these cannabinoids are made, really, whether they're intentional or not. And in addition, I'm going to talk a little bit about some of the challenges that are involved around measuring them and working with the cannabinoids. As a hint, there's more cannabinoids than meets the eye when it comes to both. Finally, I'm going to go through some real-world examples of how to kind of optimize a product that contains one or both of these cannabinoids. And I'm going to try my best to keep it really simple, but unfortunately for you guys, in a webinar format, I just won't be able to tell if everyone's eyes are glazing over. So I'm going to try really hard to try to keep it simple and not get too far into the weeds. So let's get started with Delta-8 THC. As I'm guessing many of you already know, it's generally made from hemp-derived CBD, although it is actually possible to make it from Delta-9 THC as well as some other cannabinoids. The important thing about Delta-8 THC actually is the little double bond in the diagram in the upper right there. If you look at the bottom one, that double bond is on the opposite side. So that is really the only difference between Delta-8 and Delta-9 THC. And by the way, for those of you who are kind of chemistry newbies, a double bond means that the two atoms on either side of the bond there are sharing two electrons versus a single bond, which is more common, that shares just one electron. And the atoms we're talking about here are actually carbon atoms. So those rings are rings of carbon. And in the case of Delta-8 and Delta-9, there's just one set of those two carbons that's sharing two electrons instead of one. So that one little difference is the only thing that's different between Delta-9 and Delta-8 THC. It really is kind of interesting to think about the fact that that's the only difference between them, and it alters the psychoactive properties of the molecule. But then again, the brain is a pretty complicated machine, so it's a little bit not surprising. One other chemistry fact that I wanted to let you know about that I think is kind of interesting, and I think will help understand what's going on when we start talking about these things, is if you look at both of those cannabinoids, you see two kind of hexagonal rings. These are commonly called benzene rings, and you can see two of them in Delta-8 THC. Those are common structures in chemistry. And the really interesting thing that's kind of important here is that they're actually very difficult to break apart. In fact, that's how they were first kind of discovered, is that the molecules didn't react as much as people expected them to. And as we're going to see, things can happen to those rings, meaning bonds can move around, things can connect to them, but they don't generally break apart. And what that means is generally when things happen, the cannabinoids themselves aren't going to break apart, but instead they're going to alter into different forms of a cannabinoid. Anyway, I don't want to get too far into the weeds here, so before I get in trouble, I'm going to keep going on to the next slide. So let's take a little bit of a look at how Delta-8 THC is made. If you're looking for a real recipe book on how to actually do this, you're going to be pretty disappointed here. But I wanted to give a gist of what happens, since it's really important later on when I start telling you about how much of a pain it is to test and work with. And just another note, for those of you who are really paying attention, the pictures on the right are actually not how to make Delta-8 THC. They're actually how to make lemonade, but it's kind of surprisingly similar. So don't follow those either unless it's a really hot day and you want to make something to drink. So basically what's going on is, or how it's made really is, you start with your CBD isolate or concentrate, and that's dissolved into a solvent. Usually this is something like heptane, but it's basically a solvent that's used that you're dissolving it into. And then after that, you add some acid to it. And then really all you're doing is heating and stirring it. And this usually is over a pretty long period of time. Generally something like 10 hours is common, but it can be much less or much more depending on the the processes that are used, the acids that are used, and generally just the recipe that the person making it is using. So that's really all it takes to actually make Delta-8 THC. But to make a usable product, you've got to wash out those bad solvents, and the acids you're using have got to be neutralized. And so also some folks will go as far as doing what's called preparative chromatography to further purify and isolate the Delta-8 from other of the byproducts that are made in the process. So one other thing I just want to mention here is it's really important to actually test your product here. From a safety perspective, in a process control perspective, you're going to have no idea what you've really made unless you run a test. And we'll see in a minute why it's really important to test any product that was made by someone else. The reason that this is so important is that you really don't know what you're going to get, and there's other things that could be lurking in there, including Delta-9 THC, which could be a problem if you're trying to make a hemp-compliant Delta-8 THC. And not to shamelessly plug our own Light Lab device, but that's a great tool to use for measuring Delta-8 THC and processes around it to ensure your product is what you're expecting it to be. So let's now we know how it's made, let's talk about all the other kind of fun stuff that's being made alongside it. So when you make Delta-8 with these common methods, you're actually ending up with many compounds, not just Delta-8. Some of the obvious ones are shown around here, and they're called structural isomers. But we actually don't know if these are the only things that are present. Remember, this stuff is only recently being made in large quantities, so there's not like there's a huge amount of studying going on at the moment. But what we do know is that double bond that I mentioned earlier kind of ends up playing musical chairs when the acid and heat are present. I'm not going to go into, so really, if you look at all these kind of cannabinoids I'm showing up here, you've got Delta-9, Delta-8 THC, which we've already talked about, but also Delta-10, which is over on the upper right-hand corner where that double bond is moved over once, and then Delta-6A, 10A THC, in the bottom right-hand corner at Delta-7, and then that double bond can actually also end up on the outside of the ring, and that's called exo-THC. I'm not going to get into kind of the really deep stuff on enthalpy and energy levels and things like that, but what generally happens when you make this process is Delta-8 is going to be the primary cannabinoid made because of the lowest energy state, and then there's going to be some Delta-9 and lesser amounts of some of these other compounds. And yes, that does mean that more often than not, Delta-8 is going to contain at least some Delta-9. In fact, the majority of the samples we've come across contain significant amounts of Delta-9. This is all fine and good. You've made some Delta-8. You maybe have made some Delta-9, and a few other cannabinoids are present as well. That's not necessarily the end of the world, but when you're testing for your product, this is generally done with what's called an HPLC, or high performance liquid chromatograph. That separates the cannabinoids apart over time. Light Lab actually uses a similar technique to the lab-based HPLC, so both rely on this kind of separation of compounds over time. And what you get when you're done with your separation is called a chromatogram, which I'm showing up on the screen here. And this shows peaks that correlate with the amount of each compound present. The above example is actually a hemp cannabinoid, so it's a hemp plant. And so you can see, if you look at those namings, there's CBDA, there's CBD, and both of those are in reasonably high concentrations. Those are the typical CBD cannabinoids seen in hemp. And you also have little peaks for THC and THCA, which is common. So a little bit of THC, but not much, and a lot of CBD in the hemp plant. So now I want to go ahead and switch to a cannabinoid of a sample that has Delta-8 THC in it. So in the picture above, if you look at that really tall peak there, that's the Delta-8 THC peak. And just to the left of it, there's a little lump there. That's actually the Delta-9 THC. So you can see there what's called overlapping. It's kind of hard to tell which one's which. And then further making a problem is looking at that orange arrow there. There's some other unknown peaks there. And if you remember how I said before, all those molecules that we're making are quite similar and they just have a double bond that's moving around. That means there's a lot of compounds that are really similar and they're not going to separate that well. So that's probably some of those other compounds coming out as well. And what's really happening here is Delta-8 and Delta-9 are kind of right on the limit of what an HPLC and really Light Lab as well can separate. So when you start adding a bunch of unknown components as well, things can get kind of messy. And that's why at Orange Photonics, we've had a dedicated algorithm to specifically look at Delta-8. And if it's detected, we do further analysis to kind of make sure that it's accurate and that the test is done carefully. If you don't have a light lab, you might want to consider sending samples to more than one lab, or at least talking to your lab about their Delta-8 analysis, just to make sure they will match and getting what you're expected. Because some labs are aware of these difficulties and do a really great job of kind of separating Delta-9 and Delta-8 out, while others are maybe not quite so aware of some of the difficulties here, and they could be misinterpreting peaks or misattributing peaks. So the elephant in the room really, though, is that it's kind of hard to make Delta-8 without also making Delta-9. And that's obviously a problem if you're trying to make compliant hemp products. And I do wish there was a magic bullet here, and I'm sure there are actually some brilliant chemists that are working on that. But in the meantime, I wanted to give a few ideas of what can be done about this conundrum with Delta-8, especially if your product contains a significant amount of Delta-9. And the first and most obvious thing is really just controlling your process. So if you're experimenting with many different methods, you could come up with one that has a lower amount of Delta-9 THC expressed. And one of the hints I would give on that is the longer you let the process run, the more of it's going to end up at the lower energy state, which is Delta-8, so you'll get more Delta-8. But again here, testing along the way with something like a light lab will give you an edge, so because you can really see what's going on and understand, hey, is my change here really causing a change that makes a difference to my final end product? Another method to keep Delta-9 low that's kind of involved in the process side of things is you could actually do a really short reaction time and leave a significant amount of the unreacted CBD. And what you're going to end up if you do that is a lot of CBD, a lot of Delta-8, but overall the amount of Delta-9 will be lower. So you're able to create a product that might be compliant. Yes, it's not pure Delta-8, but it's a mix of Delta-8 and CBD, which could have some appeal and market value. The second thing you can do is actually dilute your Delta-8 THC. And this is kind of the most common thing to do. And by dilute, I mean, you could put it in edibles, which dilutes it, of course. You could dilute it with an appropriate vapor dab oil, or simply dilute it back into a CBD oil. And again, here, if you're testing along the way, you can ensure your final product is what you expect it to be. And the third thing you can do is, and this works great, is actually purify your sample using preparative chromatography or a similar technique. Remember, I was mentioning the little peaks that we were showing earlier on that chromatogram. Preparative chromatography is really kind of the same thing on a big scale, and it allows you to separate the Delta-8 from different materials, and it works really well actually, but it just can be time-consuming and expensive. So in some cases, it may not very well be worth it. So let's go on to actually Delta-10 THC now, since we talked a little bit about Delta-8. Delta-10, again, is pretty simple in and of itself. As you see, but there's actually some confusion around what Delta-10 really means. The official Delta-10 is just another double bond swap we discussed earlier. In fact, it was on that list I mentioned before. But there's really two. So if you look on the right hand, the upper picture up there, you'll see that double bond on kind of the right hand side of that ring, whereas Delta-8 in the bottom is on the upper left. But there's actually two kind of confusing things here. And the first one is that, and many times, many labs, and this is getting better, but they may misidentify Delta-10 as CBC, or cannabichromine, since in most HPLC systems, they actually overlap. Light Lab gets around this by using multiple wavelength sorting analysis, so we can use both spectroscopy as well as the chromatography and separate the two out rather easily. But many labs just use a single wavelength, and if they're not aware of this issue, they may actually misidentify your Delta-10 as CBC. The other thing that's kind of confusing about Delta-10 is that what was really being made most of the time when Delta-10 is being made is a mess of compounds, just like there is with Delta-8. Now I'm going to get into that in a bit, but I wanted to talk about a little bit how it's made first, since usually it's actually an inadvertent cannabinoid it's made. It's really made when things are going wrong during kind of distillation of cannabinoids. So I want to give a quick primer on distillation of cannabinoids. Oops, sorry about that. Since this is generally where Delta-10 is created. How it works is really you take some raw cannabis oil. This is oil that's been extracted from a CO2 extractor or ethanol extractor or similar, and you put that oil into a flask and heat it up. That's what's showing there in the bottom of the little heat plate. and what you're doing is you're trying to boil those cannabinoids off, and then you capture them in another flask that's been cooled. So you heat it up, boil it, and separate it, and then cool it. And the reason you do that is you're separating things that boil at different temperatures than the cannabinoids. So you can really make a nice, maybe 90% plus pure cannabinoid in your oil. And one other point about it is generally when this is done, you're actually pulling a vacuum on this whole closed system. So you're sucking all the air out. And the reason you do that is it controls the boiling temperature and also lowers the boiling temperature so that your samples aren't sitting in that heat for too long and degrade. Usually when people think of degradation of cannabinoids from this heat and things, they're thinking of CBN or cannabinol as a degradation product. But really that's not actually, well, that is true. It's not the whole story. And I'm going to kind of show you what I mean by that here. So what I'm showing right here is a degradation pathway. Well, actually two degradation pathways from Delta-10 THC to CBN. And I think most of you are familiar with both of these compounds. But what's usually not as well known is that there are several intermediate steps to get from Delta-9 to CBN. And they're kind of, you can see them dropping through here. The upper left-hand corner is Delta-9, the lower right-hand corner is CBN. So all those other molecules in between are other steps that are required to get to CBN, or these are two of the known pathways. And the pathways do depend a little bit on environment and what's going on. So in many cases, there may be some other pathway as well, but these are two common ones. And the interesting thing is most of these intermediate steps they're not very stable, and they're going to not last very long before they degrade into the next step. But there's actually a couple of them that are quite stable, it turns out. And I'm going to show a zoomed in picture of a couple of these that will show up in a minute. So don't worry about squinting at this. I know it's a little bit small, but I just wanted to kind of point out here that the pathway to CBN isn't as simple as, oh, Delta-9, and then it heats up, and now it's CBN. There's a lot of chemistry going on in the background, and some of those other cannabinoids are going to pop out from that chemistry that's going through. So when things don't go right with the heat and the distillation process, you're tending to make a mess of compounds. And just like the mess made during the Delta-8 THC process, there's going to be several things, and in many cases, we actually don't know all the things that are created yet, which is unfortunate, but that's the state of the industry at the moment. I have put 4 of the compounds we have identified, though there are certainly others. And the 2 on the left are ones we've actually already discussed a little bit. They're just different structural isomers of THC, as I said before. So the double bond has moved around. That's Delta-10 THC and Delta-6A, 10A THC. On the right, something else is going on. So those are the same exact molecules, but if you look at the 2 orange circles, there's those 2 OHs on the molecules there. And those are called hydroxyl groups. And they're likely happening when the cannabinoids are reacting with some residual water in the whole system. So if those of you who are really good at chemistry, you might remember that H2O is water. So that means water has 2 hydrogens and 1 oxygen. So what likely happens is the hydrogen leaves as gas, and you're left with this hydroxyl group, which connects onto the cannabinoid. And so for Light Lab, when we say Delta-10 THC, we're actually grouping these 4 cannabinoids and possibly others as well into the same bucket, because they're all kind of coming from the same thing, and they're all structurally quite similar and act quite similar. It's a lot harder to say easier to say Delta-10 THC than to say Delta-10A, 6A, 10A dihydroxy THC. So that's often why people use Delta-10 THC to kind of refer to a few of these cannabinoids and degradation products. But the important thing here is that many of these degradation products all mean kind of the same thing, and that is that something is likely going wrong in your distillation process. And let's talk a little bit about what can be done about that and why it's happening. So the first line of defense, of course, is testing. So you don't really know what's in your product unless you test it, of course. And the ability to do that on site is going to end up saving you time and money. So again, I'm going to shamelessly plug our Light Lab as a great tool to do this kind of testing. But really, there's kind of 4 major things that could be going on. Some other things could happen as well, but these are kind of 4 major things that could be looked out for. And the simplest of these is the first one there, which is using too high or too much temperature and heat when you're distilling. This is going to cause degradation of the cannabinoid simply by the heat. So making sure you have not only the right temperature, but also a nice even heat through stirring and ensuring your heat is spread across the whole flask is really important. The second thing is, if you have a vacuum leak, the boiling temperature is going to go up, so those cannabinoids are going to end up stewing in that heat, and they're going to start degrading. So having poor vacuum is a sure sign you're going to get some degradation product. And third, everyone wants to, of course, get as much as you can out of your raw cannabis oil when you're distilling. But if you just let things go on and run forever and distill for much longer than typical, you're going to start to degrade things because that bottom part is going to end up being in the heat for so much time that degradation is going to occur. And then finally, extra water in the system might potentially cause these dihydroxycannabinoids I mentioned earlier. There's more likelihood that they're going to form when there's more of those hydroxyl groups or OH molecules floating around. So one final point I wanted to make, though, is that many people are actually trying to make Delta-10 or CBN or some of these other products through intentional degradation. So in that case, some of the above points can actually be used to facilitate that. But there's often other things going on, like catalysts and other processes on the chemistry side that can help add to that process and speed things along. So if you're trying to make Delta-10 THC or some of these other degradation products or even CBN, you're going to be aware of these things, and you're going to probably use some other chemistry as well to get things going. So I want to kind of summarize things here a little bit. Apologize to anyone, first of all, if that is confused here. I know there's a lot of chemistry going on, and probably even bigger apologies to any chemists that are tuning in, because this could probably be seen as a really broad generalization. So my intent here was to provide some basic background information about these kind of interesting and novel cannabinoids, and really show that it's not just Delta-10 or it's not just Delta-8, but there's really this class of cannabinoids that come from these different reactions that are people doing. And understanding that is really important to understanding what is in one of these products in a kind of a final product over sense. I'm happy to, of course, make introductions to other qualified people for folks that are interested, as well as talk to anyone that wants to kind of go a little bit deeper into this. But I think the main thing is here, if you're making or even buying Delta-8 THC, you just really need to be wary of the fact that Delta-8 THC is not really just Delta-8 THC. It's a lot of different cannabinoids, and one of them can be Delta-9. So understanding and possibly testing that is really going to be important. And similarly with Delta-10, if your distillation is going wrong and you're getting lower numbers than you're expecting, it might be good to look at that Delta-10 number or some of these degradation products to really understand what's going on and see if there's something wrong with your process. Or on the other hand, as I mentioned before, if you're looking at degradation products, you can maximize them through the same process. So really one common thread here is that in order to better understand kind of these complex products that contain these many compounds, it's really helpful to have kind of testing capabilities in-house that will ultimately make a more safe, compliant, and really consistent product. So I think that's all I've got at the moment. I know I'm a little bit quick here. Oops, let me start that up again. But if anybody has any questions or anything, I think we have time to answer a few. So I think my colleague Ashley is ready with some questions, and I'm happy to take them. So thank you very much, everyone. I really do appreciate it.
Yeah, so a question came in. You mentioned that Delta-8 has lots of different other cannabinoids in it. How much Delta-9 do you typically see in Delta-8 distillate?
Well, it really depends a lot. So when we look at some of the results we've seen internally, we see anywhere, these are on distillate samples, so they're roughly 80%, let's call it Delta-8 THC. We may see anywhere from about 5 to 25% Delta-9 THC. So it can be a fairly large component, but certainly less than half generally. From our understanding, although there's still a lot to be understood here, the longer that reaction happens, likely the lower Delta-9 THC is there, but certainly there's other factors at play. So there are ways to make some that are significantly lower, but we haven't seen any that contains absolutely no Delta-9 without a further purification step yet. So again, maybe somebody comes up with that magic bullet, but we haven't seen it yet.
And how can you tell if your lab is measuring your Delta-8 correctly?
I think there's kind of two ways. One would be I would certainly want to talk to them about what types of products and processes they're using. Some labs that we know of are intentionally running different types of programs on their HPLC to better separate Delta-8 and Delta-9 THC. So those labs will likely have a reasonably good chance of measuring accurately. Whereas other ones, if they're kind of going through a high-speed, high-throughput type of situation, they may not, in fact, be able to separate the two. So the two things I would do is get a good relationship and talk with your lab. The second thing I would say is send it to multiple labs. Or if you have a light lab, you can compare your labs with your light lab and try to see how things are matching up.
And another question that came in, what acid is typically used in the Delta-8 process?
Ooh, there's a few of them. I mean, I don't want to get into the really big details here, but I think hydrochloric acid is one. There's other kinds of Lewis acids that are used, but I'm not really well versed in the exact processes. So there may be other people I could point to that could give a little bit more information, but I know hydrochloric acid is one of them. But again, it depends. There's many, many different ways people are doing this that kind of end with a similar end result. So kind of a non-answer, but I think that's the best I can do.
And how does Light Lab measure Delta-8 differently than a normal HPLC would?
So we have kind of two things that are generally different. Labs can certainly do some of these things as well. So I'm not, certainly labs do different methods, so I can't generalize too much. But what we do is when we detect that there is Delta-8 THC in the product, we can actually further analyze things. So we take our original results, say, hey, there's Delta-8 in here, and then we can specifically look at the area where Delta-8 is and apply some other analysis and algorithms alongside our current ones and do a better job of separating the two out. So what we're really doing is taking a single pass at it, saying, hey, there's Delta-8 in here, and then we say, okay, now we've got to look closer at that one area where the overlaps are occurring and do a careful job of separating those two out. That's a real simple way of doing it, but essentially that's how we are approaching this.
Does the original Light Lab measure Delta-8?
Unfortunately, it does not. So our newer Light Lab, which is called Light Lab 3, is a higher resolution system, so it's able to do the separation that's required here. But as I've shown in those chromatograms, you can see it's a little difficult to separate the two. So the original Light Lab, while it still works as a good tool, it just doesn't have the resolution to be able to separate those two. So then there is certainly upgrade processes as well for that kind of thing. So if you do have a Light Lab 2 and you're interested in measuring these, definitely contact our sales team or myself.
And an interesting question, what other minor cannabinoids might you expect to see hit the market next?
I don't have a great magic ball, but I can give you my opinion anyway, so take it with a grain of salt. My feeling is people have been talking about them a fair amount for a while now, but some of these varin cannabinoids, so CBDV, CBDVA, THCVA, and THCV are likely to start cropping up more and more. Although people have been talking about them, and we found that one of the challenges we have is something that to measure these is actually finding real world samples in the wild that contain them. And we've just started to see some samples that actually contain significant amounts of these cannabinoids. So that's why I think that they're likely coming along, and we're going to work really hard to work with those new kind of novel cannabinoids. But I would look closely at varin species and varin cannabinoids.
Great, thank you. I think that we are just about out of time to take any more questions. If we didn't answer your question, someone will be in touch with you. And thanks, Dylan.
Yeah, thank you so much, everyone. I appreciate it.